Hi. So in this video we're going to have a look at special angles. Okay. So special angles are quite important, okay? And we use them in right angled triangles. Okay. All right. We use them in right angled triangles, and we also use them when we want to avoid using a calculator. All right. So it involves two triangles, okay? The first of which involves 45-degree angles. So if we draw a triangle here, okay, draw a triangle here like this, like so, and you've got a 90-degree in there, and you got this angle is 45, and you got another 45 here, okay. We see that if we start off with having a base of 1 and a length of 1 for the height, and we want to work out this r here, we can use Theorem of Pythagoras. So Theorem of Pythagoras we've just discussed is x squared plus y squared equal to r squared, okay? So we're going to call this side here x, we're going to call this side here y, and then obviously r. So if we do that, we see that we get r squared 1, and we substitute in there, then that gives us 2, that gives us r squared. Then we see that we get square root of 2 for r. Okay. Now just remember that r is always positive, the hypotenuse is always positive, so it would always be the positive square root of 2. So remember, when you square root a function, or you square root anything, it gives you a positive and negative, but you'd only choose the positive here because of that positive nature of the hypotenuse. Okay, so if we apply our trigonometric ratios here, right? So if we apply our SOHCAHTOA, okay, so SOHCAHTOA, all right, we see that for the sine, let's make this a bit smaller here. Okay, we want to make this a bit smaller so we have some space in here. Okay, so if we take sine of 45, okay, so which 45 are we dealing with here? Let's just pick this one. So we're dealing with this 45, so we know that this would be our opposite side, and we know that this would be our adjacent side, and this then would be obviously the hypotenuse side. So coming down here, sine of 45, we see that we would get opposite side, which is 1, and then obviously we just calculated this right now. We know that that's going to be root 2. So if we fold that in here quickly, we see that this becomes the square root of 2. So filling that in, we see that we get 1 over the square root of 2, okay, which is sine 45. And if we come back in here and have a look at cos of 45, we see that that gives us the adjacent, coming back to SOHCAHTOA, the adjacent over the hypotenuse. So in terms of the adjacent side, that has a value of 1, okay, and then obviously our hypotenuse, which you just figured out, has a value of root 2, okay. All right, so then if we finish this triangle up by looking at tan, okay, so tan 45, that would give us the opposite over the adjacent, which would simply be 1 over 1. All right. Right, so this is the first triangle, okay? This is the first triangle that you need to understand, okay? And the second one would then be involving 30 and 60 degrees. So this would be special angles continued. Special angles continued. Okay, so this would be the second triangle then. So if we take the second triangle, okay, and we have a look here, and this angle is 60 degrees, and this one is 30 degrees. Okay, those are our angles there. And then obviously this would be our 90 degrees. If we start off and say this base length is 1 unit, and the hypotenuse is 2 units, then we can then go ahead and find out what our y value is. If we say y, okay, so we go with Theorem of Pythagoras, x squared plus y squared equals r squared. So here our x would be 1 squared, our y squared is unknown, and then our r we can substitute in, put in 2 squared. So if we move things around, okay, we'd get 2 squared, which is 4 minus 1. And if we square both sides, we get square root of 3. Okay, here again we're going to take it as positive because we aren't in the Cartesian plane and we aren't dealing with negative values yet, so we take that as positive root 3. Alright, so then if we go on and if we write the trig ratios for this, okay, we see firstly, let's label our little triangle. So if we label our triangle, okay, let's start with the opposite side. So this being the opposite, okay, and obviously we've worked it out, it's root 3, okay, and then if we go with our adjacent, our hypotenuse, that would be our hypotenuse, and then you'd have your adjacent here. Okay, so this is working off the 60, okay. So if we look at the 60 degrees, okay, let's write our special angles out for that. We look at the 60 degrees, we'd have sine of 60 degrees, which would give us our opposite, which is, let's write our secateurs in here, secateurs, okay. So it would be opposite over hypotenuse, which would be the square root of 3, okay, divided by your hypotenuse side, which is 2, and then cos of 60 would be your adjacent over your hypotenuse. So your adjacent would be 1 over your hypotenuse, which is 2, okay. And looking at tan of 60, you have opposite over adjacent, so your opposite side would be square root of 3 divided by your adjacent, which would then just be 1. Okay, so we've got some exact values in here. All right, a lot of the time when you deal with these trig ratios, especially when you have numbers that are not special angles, you're going to be getting a lot of decimals. Okay, so these give you nice exact values, not non-terminating decimals. Okay, for those maths lovers out there. So on the same light, if we have a look at the values of the 30 degrees, okay, so if we look at the values of the 30 degrees, so if we move this up here, then we can examine 30 as well. So if we go ahead, okay, if we go ahead and redraw this triangle, okay, so let's try and redraw this triangle. If we go ahead and redraw this triangle, so let's copy it down, take it over to the next screen. Okay, paste that in there. Okay, so what I want to do now is I want to examine 30 as being the angle that I'm working off of. So obviously now these adjacent and the way I label my triangle is going to change. Okay, but something that's not going to change is going to be this value here. It's still going to be the square root of 3. Alright, so going ahead here now and using 30 as my main angle. Okay, so if I go opposite to 30 now, I'm going to come here. I go opposite to 30. So we're examining 30. This would be my opposite side. Okay, and then my hypotenuse would be the same. That hasn't changed. Okay, but the opposite and adjacent have switched over. So this would be my new adjacent. Okay, so if I go ahead and do my secateurs here, I get sine. Okay, now I'm dealing with 30 degrees is equal to the opposite over the hypotenuse. So my opposite in this case would be 1, okay? And my hypotenuse there would still be 2, okay? So sine of 30 would give you 1 over 2, right? And then your cos of 30 would be adjacent over hypotenuse. So your adjacent now would be root 3 over the hypotenuse, which would be 2 still, okay? And then my tangent of 30, okay? That's going to be opposite over adjacent. So the opposite is still going to be 1, and the adjacent obviously would then be root 3.